Hello students, today we are going to discuss real numbers, chapter first of your NCERT book 10th standard. In this chapter we are going to discuss prime numbers, factors, co-primes, composite numbers, rational numbers and irrational numbers. Now let us come to exercise 1.1, question number 1. Express each number as a product of its prime factors. First of all, we must know what is the meaning of prime factors. Prime numbers are those numbers which are divisible by number itself, like 2, 3, not 4, because 4 is divisible by 2 and 4 both. 5, not 6, so 6 again divisible by 2, 3 and 6. Now 7, likewise. So prime numbers are those numbers which are divisible by 2, 3, 5, 7 and so on. And factors are the numbers which divides the other number, like suppose 2 is divisible by 2, so 2 is a factor of 2. 2 is a factor of 2. Now 2 and 4 are the factors of 4. So because 2 is dividing 4 and 4 is also dividing 4, it means 2 and 4 are the factors, though 1 is also a factor of 4. So 1, 2 and 4 are the factors of 4. In this case also 1 is also a factor of 2. So 1 and 2 are the factors of 2. Okay. So now let us come to the question. Let us come to question number first part. Express 140 as a product of its prime factors. Now our first prime number is 2. If we divide 140 by 2, we will get 70. If we divide 70 by again 2, we will get 35. Next prime number could be 3, but we will not take 3 because 35 is not divisible by 3. 4 is not a prime number. Now we will take 5. If we divide 35 by 5, we will get 7. Now 7 divided by 7, 1. Because we will not take 6, because 6 is not dividing 7, or 7 is not divisible by 6. Here 2 into 2 into 5 into 7 equals to 140. It means these 4 are the prime factors of 140. Means 2 is dividing 140, 5 is also dividing 140, 7 is also dividing 140. Multiplication of all these 4 will become 140, and individually also these 3 numbers are dividing 140 also. So prime factors of 140 are 2 into 2 into 5 into 7, or we can write it like that also. Okay, is it clear? Now let's move to the second part of the question number 156. Our first prime number will be 2. If we divide 156 by 2, we will get 78. Again, if we divide 78 by 2, we will get 39. Now we can take 3 because 39 is divisible by 3. 39. Now 13 is divisible by 13. So prime factorizations of 156 is 2 into 2 into 3 into 13. It is 156. So again 2, 2, 3, 13. These 4 are the prime factors of 156, which multiplication of this is equal to 156, and 2, 3 and 13 are individually also dividing 156. Okay. Now let's come to the third part of the first question. Third part is 3825. Let us try with the first number 3. 1275. Again we can try with 3. 4, 2, 5. Now it is not divisible by 3. Let me tell you one thing here. Let me complete and I will explain why I am taking these numbers or why I am skipping other numbers also. Now 85 is divisible by 5 and we will get 17. Now 17 again we will get 1. Here we did not start with, first of all you must see, here we did not start with 2. 2 is the lowest prime number. We did not start with 2 because for a number to be divisible by 2, it should end with an even number. Here 5 is an odd number, so we will not take 2. Why we have started with 3? Because it's a divisibility rule. If a number has to be divided by 2, it should end with an even number. So here 5 is an odd number, so we'll try it with 3. So now how to check whether it is divisible by 3 or not, we will see the sum divisibility rule. 3 plus 8 11, 11 plus 2 13, 13 plus 5 18. 18 is divisible by 3, so we have tried, it is divisible by 3. Is it clear? Why we have taken 3? Because the sum of these numbers is divisible by 3. Again 1275, sum of these 4 numbers is divisible by 3. Now 4 to 5, sum of these 4 numbers 4, 2, 5, 3 is not divisible by 3. So we have taken 5 because 5 is at the end of the number there is 5. 5 is divisible by 5. Now 425 divided by 5 we will get 85. 85 again divisible by 5 we will get 17. So prime products are 3 into 3 into 5 into 5 into 17 equals to 3825. The prime factors of these 3825 is 3, 3, 5, 5, 17. It can be written as is it fine? Now let's go to the fourth part of the first question. Our fourth part is 5, 5005. Now let us make the prime factorization of this number. Again we have to try with 5. The reason it is ending with 5, the number is ending with 5, so it will be divisible by 5. 5005 divided by 5 we will get 1001. Now next number will be 7. If we divide 1001 by 7 we will get 143. So 143 is again divisible by 11 and we will get 13 as a result. Now 13 divided by 13 will get. So prime factors are 5 into 7 into 11 into 13 is equal to 5005. Here I just want to clear why I have taken 5 is because 5005 I have told before also, it is not ending with 5 2 any even number, so it is not divisible by 2. Sum is not divisible by 3, that's why we have not taken 3 also. We have started with 5, 6 not even a prime number, so 1001 is not divisible by 5, we have taken 7. It's a trial method, we have to see, we must know the divisibility rules as well as we have to try also by which number the digit this number is divisible. So 1001 divisible by 7 we will get 143. Again 11, if we divide 143 by 11 we will get 13. 13 is divisible by 13 we will get 1. So prime factorization of 5005 is 5 into 7 into 11 into 13. Now let's go to the fifth part. Sorry. This is 7429. Here we have to see by which number 7429 is divisible. In this one we have to try with 2, 3, 5, 7, 11. So we come to the conclusion that it is divisible by 17. If we divide 7429 we will get to know that we will get 437. And again 437 we have to try. If we divide by 19 we will get 23. So 23 1. So prime factorization of 7429 are 17 into 19 into 23 equals to 7429. I think it is clear to all of you. Now let us move to question number 2. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. First of all, we must know the meaning of LCM, HCF, and there is also one rule. If we multiply LCM into HCF, if we calculate the LCM and HCF of two numbers, the product of LCM and HCF is equal to product of those two numbers. How it will work, I will explain you later. First of all, you must understand this is an equation. LCM and HCF of two numbers. Is equal to product of those two numbers. Okay. And what is LCM? And first of all, we must know the meaning of LCM. LCM means least common multiple. Least common multiple. How we calculate the LCM and how we calculate the HCF, that I will tell you while doing the question. LCM means least common multiple. And HCF, highest common factor. Just listen to me carefully. This is multiple. LCM is multiple and HCF is factor. There is a difference in multiple and factor. Factor divides the number. Factor divides the number. Multiple is divisible by the number. LCM is multiple, least common multiple is multiple means a number which is divisible by the number. Factor divides the number, or multiple is divisible by the number. Okay, now let's solve the question. We will know how to calculate LCM and HCF. And here one thing also I have told you, there is an equation. LCM and HCF of two numbers is equal to product of those two numbers. That also you keep in your mind. Okay. Our first part is find the LCM of 26 and 91. So first 26, we make the prime factors of 26. The prime factors of 26 are 2 and 13. Prime factors that just now we have done in our first question. We know how to make the prime factors. Prime factors of 26 are 2 and 13. Now 91. Prime factors of 91 are 7 and 13. 26. The prime factors of 26 are 2 and 13. Prime factors of 91 are 7 and 13. Now we will calculate HCM, HCF and LCM one by one. Let us calculate LCM first. In the case of LCM, first we will write the prime factors of first number 2 and 13. And now 2 and 13 we have written. Now let's come to the second number. Here 13 has come already. We will not write 13. We will write only 17. So 2 into 13 into 7. It will come 182. What is the meaning of least common multiple? It means 182 is divisible by 26 and 91 both. If we divide 182 by 26, it is divisible, fully divisible. If we divide 182 by 26, it is possible, and we can divide 182 by 91 as well as 26 both. Least common multiple means when a number is divisible by both the numbers, means 26 and 91 both. Now HCF. In case of HCF, we will write the number which is common in both of them, like 13. 13 is the common number. Means 13 can divide 26 as well as 91. I repeat, in case of LCM, 182. 182 is divisible by 26 and 91. In case of HCF, there is a difference in LCM and HCF. HCF is the number which divides both the number, and LCM is the number which is divisible by both the numbers. Okay, so LCM we have calculated, HCF we have calculated. Now the question is asking us to verify that LCM and HCF is equal to product of these two numbers. We will calculate the product of LCM and HCF. 182 into 13. But we will get, if we multiply 182 into 13, we will get 2366. And product of these two numbers, 26 and 91, is equal to, if we multiply these two numbers, we will again get 2366. So this is verified. Let's do another example for better understanding. Our next example is find the LCM and HCF of 510 and 92. Again, 512 prime factors of 510, 2, 3, 5 and 17. Do you want me to calculate how I have done these factors? If you want, I can show you also. 510, 2. Is it clear to all of you? 2, 255. Now 3, now it will go by 5. So from here I have got this 2, 3, 5, 17. This is a part of our graph calculation. Or you can show here also in the main question also. This is not a problem. Here actually this all we have done already. So I calculate the factors of, now I make the factors of 92. Factors of 92 are 2, 2, 23. Now LCM. Same way. First 4 factors we will write as it is. And now the numbers which are already repeated we will not write. 2 already has come one time, we will not write. 2 has in the second, for the factors of 92 are 2, 2, 23. 2 is there, 2 already has come, we will not write. Repetition is not allowed. 2 is 2 times, so we'll write one more 2 here. 23 has not come, we will write 23. So LCM will become, if we multiply all of them, we will get 2, 3, 4, 6, 0. 2, 3, 4, 6, 0. Now we will calculate HCF. Which number is coming? Which number is repeated? This 2 only. 3, 5, 17. It is not coming. So HCF is 2. LCM means 2, 3, 4, 2, 3, 4, 6, 0 is divisible by 510 and 92. HCF 2 means 2 will divide 510 and 92 both. There is no other number which will divide 510 and 92 except 2, and LCM also 2, 3, 4, 6, 0 is divisible by both 510 and 92. Again here also we will calculate the product of LCM and HCF, means 2, 3, 4, 6, 0 into 2, and we will get 46920, and product of 510 into 92, we will get 46920. Hence it is again verified. So LCM, what is LCM, what is HCF, and there is one rule also. In case of two numbers, in case of only two numbers, I am not saying it is in case of 3 numbers or 4 numbers. In case of 2 numbers, if we multiply these 2 numbers, their product will be equal to their product of their LCM and HCF. If we multiply LCM and HCF and we multiply those 2 numbers, we will get the same result as we have shown here. Okay. Now let us come to the third part. Third part is three, 6 and 54. Now prime factors of 336. If you want, I can show you also how we have calculated the prime factors of 336 for your better understanding. We can try with 2. If we divide 336 by 2, we will get 168. Now 168 again we can try with 2. If we divide 168 by 2, we will get 84. Now 84 again we can divide with 2. It will get 42. Again we can divide 42 by 2, we will get 21. Now 21 is not divisible by 2, we will try with 3. We will get 7. Now 7 we divide, we will get 1. So here we will write, just see this question very carefully. 2 into 2 into 2 into 2. 2 is coming 4 times. 3 into 7. Okay. Now let's come to the second digit, second number. It is 54. The factors of 54 are, if you want I can show you over here, factors of 54 also. 2, 27, 3, 9, 3, 3, 3, 1. So factors of 54 are prime factors. I mean prime factors 3, 2, 3, 3, 3. 3 times 3. Now LCM. We will write the first factors as it is. 2 into 2 into 2 into 2 into 3 into 7. Students, I just want to clear one thing. There are different ways to calculate LCM and HCF. But the way what I am telling to you is, it is different. It may be a different way, but I think it is very convenient and very easy to understand. First we have to write, we will not get confused. First we have to write all the numbers, all the factors of the first number. Now let's come to the second. We have written all the factors of first number. Now 2 already has come one time, we will not write. 3 one time it has come. Now 3 in the second number, 3 is coming 3 times. 3 is coming 3 times, but in the first number it has come only one time. So 2 time it is extra here. So we will write 3 into 3. So LCM will become product of all these numbers, and we will get LCM as 3024. Now HCF. HCF again, the number which is repeating in both of them. 2 is coming, 2. Now 3. So it will become 6. So now 6 is the number which can divide 336 and 54, and 3024 is a number which is divisible by 336 and 54. So 336 and 54 can divide 3024, and 336 and 54 can be divided by 6. It means that. Now we will calculate LCM and HCF product. 3024 into 6. If we multiply 3024 into 6, we will get 18144. And if we multiply 336 into 54, we will get 18144. Both are same, hence it is verified. Again I repeat, if we multiply LCM and HCF of two numbers, we will get the sum equal to the product of those two numbers. Okay. Now let us come to the question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. Same, but the difference is, in the earlier question there are two numbers for which we were calculating LCM and HCF. Now in this question there are three numbers, very small numbers are there. We have to calculate LCM and HCF of the following numbers by applying the prime factorization method. Again, let's take the first part. prime factorization of 12 is equal to, the prime factorization of 12, 2 into 2 into 2 into 3, 15. 3 into 5, 21. 21 prime factorization of 21 is 3 into 7. Prime factorization we know very well. 12 prime factors of 12 are 2, 2, 2 into 3, and 15, 3 into 5, 21, 3 into 7. Now LCM. LCM is same. 2 into 2 into 2 into 3. 3 has come already, 3 we will not take. 5 has not come. 5 is not taken, so we will take 5. Now let's go to the third number. 3 has come already, we will not take 3. No, 7 has not come, we will take 7. The LCM will become the product of all these 1, 2, 3, 4, 5, 6 number, and our LCM will be, if we multiply these numbers, we will get 420. Now HCF. How will calculate the HCF? We will see the number which is common in all of these numbers. I think this is 3 only. So HCF is 3. In this question, LCM is 420 and HCF is 3. I repeat the meaning of LCM. 420 is divisible by 12, 15 and 21. And 12, 15 and 21 are divisible by 3. 12, 15 and 21 are divisible by 3. And 420 is divisible by 12, 15 and 21. Now come to the question number second part of question number third. Second part is LCM and HCF of 17, 23 and 29. First we will take 17. Prime factors of 17 are very simple. 1 into 17 or 17 only. Then 23. Prime factors of 23 are 1 into 23 or only 23. Prime factors of 29 are 1 into 29 or only 29. LCM 1 into 17 into 23 into 29. Why 1 into 17? If you multiply 1 into 17, it means 17 only. So first we have taken 1 into 17. Then 23 has not come, we will take 23. Now here 29 has not come, we may have taken 29 also. If we multiply all of them, we will get LCM as 11339. Now HCF. Now here you will understand why I have written 1 here. Otherwise 1 is not required, but why I have written 1 here? Because HCF is 1 here, because 1 is the common factor. These three numbers are divisible by 1, 17, 23 and 29. So HCF is 1, and 11399 is divisible by 17, 23 and 29. 11339 is divisible by 17, 23 and 29, and 17, 23 and 29 are divisible by 1. So HCF is 1. Okay. Now let us come to the question number 4. Now see, given that HCF of 306 and 657 is equal to 9. Now here we are given HCF of 306 and 657 is 9. Find LCM of 306 and 657. When two numbers are given, 306 and 657, it is very simple to calculate LCM. There is if two numbers are given, 306 657, we can find the LCM without by finding the prime factorization. You know it very well. We will write 306. We will make factors. 657. We will make factors. Then LCM we can know. But here he doesn't want in this way. The question is not asking us to calculate in this way because he is given the HCF also. So we will go to that equation where LCM into HCF, product of LCM and HCF is equal to product of numbers, two numbers. LCM we have to calculate. HCF is given 9, that is it is here. Product of those two numbers 306 and 657. Here LCM is equal to LCM into 9. 9 is multiplying with LCM. Here and 9 is multiplied with LCM. So here it is multiplying. If it goes to another side, it will divide the other side. 306 into 657 divided by 9. If we solve these two, we will get 22338 as a LCM. So our LCM is 22338. This you can solve 306 into 657 divided by 9, or 9 also you can divide 306 by 9, and whatever we get the result, we can multiply it with 657. I repeat here once again. In this question, we are given 306 and 657. These are the two numbers. Simply by prime factorization 306 and 657, we can calculate the LCM. But here we cannot use that form this way because here HCF is also given. If HCF is given and two numbers are given, we will put in this equation where LCM and HCF of two numbers is equal to LCM and into HCF of two numbers is equal to product of those two numbers. So LCM into 9, LCM into HCF is 9. We have written 9 here is equal to product of two numbers 306 into 657. Now if we solve this, we will get LCM as 22338. Okay. Now let's go to question number 5. Yeah, this is an interesting question, but I will tell you the simplest way to solve this question. First of all, read the question. Check whether 6 raised to the power n can end with the digit 0 for any natural number n. But let us forget about n first. Let us see what are the prime factors of 6. This is a prime till now we have done prime factors only. So let us concentrate on prime factors only. So prime factors of 6 are 1, 2, 3 and 6. Prime factors of 6 are 1, 2, 3, 6. Oh, sorry. Not prime factor, these are the factors of. Prime factors of 6 are 2 and 3. Means 2 can also divide 6 and 3 can also divide 6. And there is a condition that if a number has to end with the digit 0, let's take any number, 10, 20, 30, 40. All these numbers are ending with 0. For a number to end with 0, it should have common factor like, it should have the factor like 2 and 5. In 20's case, 2 into 2 into 5, likewise. So it should have 5 as a factor. For a number to end with the digit 0, there should be 5 as a factor. But in case of 6, 5 is not the factor of 6. Therefore, we can say there is no number n for which 6 raised to the power n ends with digit 0. I repeat once again. First, we will calculate the prime factors of 6, that are 2 and 3. And now we will see, here it is saying we have to calculate, it should end with the digit 0. For any number to end with 0, it should have 5 as a factor. But here 2 and 3 are the factors, 5 is not the factor. So therefore we can say there is no number n for which 6 raised to the power n ends with the digit 0. Now composite numbers. First of all, we should, okay, let's read question number 6. Question number 6 says, explain why 7 into 11 into 13 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. First of all, we must know the meaning of composite number. Composite numbers means having more than 2 factors. Composite numbers which are having factors more than 2 factors, like 4. 4 is a composite number. It has factors 2, 1, 2 and 4. 2 is not a composite number because it has only 2 factors, 1 and 2. 3 is also not a composite number. It has only 2 factors, 1 and 3. After that, 4 is a composite number. 5 again has 2 factors, 1 and 5. 6 is again a composite number. Factors 1, 2, 3 and 6. So it has 4 factors. So this is a composite number. When a number is having more than 2 factors, it is called composite number. Now explain. Now let's come to the question. Let us solve one by one. 7 into 11 into 13, plus 13. If we solve this, 13 is common in both of them. First we will divide into 2 parts. This is the one part, this is the one part. 13 is available in both of them. We will take 13 as a common. Now we will get 7 into 11 plus 1. If we take from this number 7 into 11 into 13, we will take 13. I will tell you how to take common also. Plus, this is plus, and 13 1. Let us see how to take common. 7 into 11 into 13. If we take common, what we have to do? We write the number and divide the number which we are taking common. This will cancel out. We are left with 7 and 11 that I have written here. Now plus sign I have shown. Now from 13 we are taking 13 common. 13 divided by 13 will get 1. I have written 1 here. So again I solve it. 7 into 11 77 plus 1 13 into 78. Okay. So here we can see this is a number 13 into 78. If we multiply 13 into 78, here factors will come 13. If we take the prime factorization of 78, we will know that prime factorization of 78 will be something 13 into 2 into 3. So this has more than 2 factors. So this we can say 1, 2, 3, 4 and of course 1 also. It has 5 factors. So we can say this is a composite number. Okay. Now let's go to the second part. Now our second part is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here in first we will make a partition. Here plus sign comes. We will make two parts. First part, second part. Here we will see that 5 is common in both of them. We will take 5 common. We are left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. Again if we multiply all of them together, we will get 1008 plus 1. 5 is equal to 5 into, if we multiply 1, we will get 5 into 1009. So this is again a composite number. Again it has more than 2 factors. 5 into 1009 and 1. This is most important because 1009 may not have factors. 1009 may not have factors. So after seeing these two, you can see that it is a composite. It is not a composite number, only having 2 factors. It is not having more than 2 factors, but it is having more than 2 factors. That is 1 is also included. So it will become, it has 3 factors. So it will become more than, it has more than 3 factors. So it will be a composite number. Now let's move on to our question number 7. This is the last question of the exercise number 1.1. Let us read the question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? For this question, there can be different and many ways to solve this question, but the way which I am going to tell you is very unique. Let's see. We can calculate either HCF. In this chapter we have calculated only LCM and HCF. We can calculate in this question either LCM or HCF. LCM and HCF of we can calculate either LCM and HCF of 18 minutes and 12 minutes. If we calculate LCM, if we calculate HCF of 18 and 12, we will get 6. Means after 6 minutes, can they meet? Can they meet after 6 minutes? Because he is taking 18 minutes and he is taking 12 minutes. How they can meet after 6 minutes? So surely we are left with the option of calculating LCM. I repeat once again. Sometimes we get confused what is to be calculated. Should we calculate LCM or should we calculate HCF? So if we calculate LCM, HCF will be 18, HCF of 18 and 12 will be 6. Can they meet after 6 minutes? One person is taking 18 minutes and one person is taking 12 minutes. So they can't meet after 6 minutes. So better we go for LCM. So LCM is LCM of 18 and 12. Here prime factors of 18 are 2 and prime factors of 12 are 2 into 3 into 3. Now 2, 3, 3 we have written. Now 2 has already come, we will not take. This 2, only one time it has come, we will take 2, one more 2. If we multiply these 2, we will get 2 into 3, 6 and 2 into 3, 6 into 6, which is 36 minutes. Writing unit is very much important in these question word problems. If we don't write minutes or any units, we may lose marks. So after 36 minutes, they can meet. I can show you this question with the help of a figure also. Suppose this is a circular path. Okay. Sonia starts from here and she is taking 18 minutes to complete the path. Okay. Now Ravi also starts from here. He also starts from here and he comes back in 12 minutes. So if answer is 36 minutes means Sonia will make 2 rounds. 36 is divisible by 18 means so in 36 minutes Sonia will make 2 rounds of this circular path. Are you trying to follow me? Sonia will take 2 rounds in 36 minutes because she is taking 18 minutes to complete 1 round. Now in case of Ravi, he is taking 12 minutes. In 36 minutes, he will take 3 rounds. So after two rounds, Sonia will come here and after 12 minutes, that means after 36 minutes and completing 3 rounds, Ravi will also come here. So they will meet at the starting points after 36 minutes. So after 36 minutes, they both can meet here. Sonia will make 3 rounds and Ravi will make 2 rounds. Now with this, I conclude exercise 1.1 and we will see you in the next class. Thank you.